Hey everybody, so for our preview today for section 2.5, we're going to start by talking about functions written in implicit form versus functions written in explicit form. We're most familiar with functions written in explicit form because they take on the appearance of being solved for y. Like y equals 2x plus 3 is an example of an equation in explicit form. Implicit form would be an equation such as x plus y squared equal to 7. So this equation isn't solved for y. We don't have y by itself, so we would say it's an implicit form. Well, in this first equation, we can take and rewrite it in explicit form by working to solve for y. So first we're going to do that by getting y squared isolated. We'll have y squared is equal to 7 minus x. And then to get y completely alone, I know I have to take the square root of 7 minus x. And because I'm taking the square root, in order to isolate y, I need to put plus or minus out in front. So in explicit form, our equation becomes y equals plus or minus the square root of 7 minus x. In a second example, let's take a look at x times y equals 3. Now that's really easy to turn into explicit form. All we need to do is divide both sides by x, and we get the equation y equals 3 divided by x. And again, that's an explicit form because it's solved for y. So our next question would be, can we rewrite all questions or all equations in explicit form? And the simple answer is no. And for example, if I just move this up a little bit, give you an example, x squared minus 2y cubed plus 4y equal to 2. So if we work to solve that for y, the first thing that I would do is probably subtract x squared from both sides. So you get 2y to the third plus 4y is equal to 2 minus x squared. So I have all the terms that have y's in it on the left-hand side here. All right, all I can do next is factor out a negative 2y, and that would leave us with y squared minus 2 inside the parentheses. And this doesn't really help me to solve for y because I still have a y here, and I have y squared inside the parentheses. So it's impossible for us to isolate y. So since we cannot isolate y, we cannot write this equation in explicit form. Okay, so if our equation cannot be written in explicit form, how will we take the derivative? And that's what we're going to focus on next. So we have to use implicit differentiation to find the derivative of a function that cannot be written explicitly. So if you're in that situation where you cannot rewrite an equation in terms of y, like y equals everything else, then you have to use the following process. We're going to differentiate the terms involving x as usual, so apply the power rule and do it normally. But when differentiating terms involving y, we have to apply the chain rule because y is defined implicitly as a function of x. So in our first example, where we're finding the derivative of each expression, we're also going to find derivatives of equations too, and that will be part of tomorrow's lesson. In our first example, we want to find the derivative of 3y to the fifth. Notice right here that it's a derivative of y in terms of x. The variables do not match. So we're going to apply the chain rule. So first take your 5, multiply it by the 3 that's out in front, and we'll get 15 y to the fourth. And now we have to take the derivative of y. Now, it's the derivative of y in terms of x, so what we'll just put on the end here, we're going to multiply by the derivative of y in terms of x. So when you're doing implicit differentiation, you're going to see this piece on the end whenever you're taking the derivative of any terms involving y. Okay, let's try the next one. We're taking the derivative of x squared plus 4y squared in terms of x. Notice that these variables match, so just do it normally. So the derivative of x squared would give us 2x plus, now we're going to take the derivative in terms of x of 4y squared. This is the implicit part. So apply the power rule. So 2 times 4 gives us 8y to the first, and then we're going to multiply by the derivative of y. So you say derivative of y in terms of x. And that's it. That's our final answer. Okay, with our last example, we have to apply the product rule. Notice that we have multiplication here. We have 2 terms. So applying the product rule, the first variables match. So we're going to take the derivative of x cubed. That gives us 3x squared. And in the product rule, we keep the second function the same, so it would be y squared. So that's a squared there. In the product rule, we add. Now we keep the first function the same, so we have x cubed, and it's times the derivative of the second. But again, the second function here is y squared, so we have to apply the chain rule to just that piece. So it'll be multiplied by 2y, and then we have to take the derivative of y itself, which would be dy over dx. The only thing that I would do to clean up the answer a little bit is bring this 2 out in front. You bring all those monomials out in front. So our final answer for the derivative of x cubed times y squared would be 3x squared y squared plus 2x cubed y dy dx. Final answer. Okay, tomorrow we'll take this further and look at how we take the derivative of an equation, and then we'll do some practice together in class.